Hello, welcome to this example. This is an intimidating problem, so we're going to go through it together. It does give us a formula, so that's super helpful, but there is a lot going on and a lot of confusing terms here. So according to Newton's law of cooling, an object with a temperature of T1 is placed in an environment with a temperature of T0. The object will adjust to a temperature of T after T minutes, where we have this big old formula. So what on earth do all these T's mean? So the first one says an object with a temperature of T1. So this is my starting temp. Placed in an environment with temperature of T0. So this is my room temperature. Will adjust to a temperature of T. So this is my final temperature. After T minutes, so this lowercase t is my time. All right, so we're going to go to the orange box and we're going to try to plug in all of those different pieces into this formula and see what it wants us to figure out from there. So it says a drink is removed from the fridge. It has a temperature of 40 degrees. So that is my T1 value because that is the temperature that it is when it starts, removed from the fridge. And it is set in a room with a temperature of 72 degrees. So that is a T0 because that's a room temperature. 10 minutes later, so that is lowercase t because that is time. The temperature of the drink is 48, so that is plain old T because that is the ending temperature. We're asked what is the value of K. So we're going to go to our formula. The T without a subscript is the plain old T, and it's in the formula as T of T, temperature based on time. And so we are going to replace temperature. Let me actually write this down here. So T of T, we're going to replace that with the ending temperature of 48. Then we've got an equal. T0, so equals T0, we said is 72. Then we have a plus sign. Then in parentheses here, we have T1 minus T0. So T1, we said is 40, minus T0, which we said is 72. Then we've got an E, which we know is a constant. We know that that's on our calculator. We have a negative K, T. T we know is time when it's that lowercase one, so that's a 10. All right, so we have parentheses and we can do the math inside the parentheses. So I'm going to do the math inside the parentheses. 40 minus 72 on my calculator gives me a negative 32. So cleaning this up a bit, 48 equals 72 plus a negative 32 E, and then I'm going to rewrite this exponent in the normal math notation where we put the numbers in front of the variables, so to a negative 10K. So that's what I have just from cleaning up the formula. Okay. Now, it is going to be tempting to want to take the 72 and minus the 32 because it looks like that might be the next step of math, but it's not. The reason why it's not is because this negative 32 is not a like term to the 72. The 72 does not have an E beside it, and it does not have an exponent. So because they're not like terms, that's as cleaned up as we can get it. And in this problem, I have an unknown exponent. And that means that it is not a handheld calculator friendly problem. So because that unknown exponent, typically we had unknown time, but truly those times were all these exponents. So this unknown exponent is pointing me to use Desmos, or if I want to solve it by hand, a logarithm. So this entire presentation is focused on using Desmos, so that's where I'm going to go again. So I go get my graphing calculator, Desmos, and like we have done every single time, we have to make each side of this be its own equation. So over here, I'm going to make this be y equals 48. And on the other side, all of this is my y equals 72 minus 32e to the negative 10, and that k will have to be an x in Desmos. Now, you'll notice as I prepared this to type, I did not write plus a negative, and you may write plus a negative, or you can keep that as a subtraction, which is how I put it, so that it's just a little bit less to type. So let me clear out the stuff we have in Desmos. I'm going to reset my Desmos graph over here to the home, so that I'm back at the beginning, kind of reset the whole thing. So my first equation, y equals 48, so that one's easy to type. Second equation, y equals 72, subtract 32e, and you can just use the e right off of your keyboard, so you don't need anything special there. And then shift and the number 6 gets me the caret key to get up to the exponent, and my exponent here is negative 10x. Now, I don't see a lot happening on my graph, but I do see a little bit. I see that there is a blue line, and that blue line looks to be like superimposed on top of the axis, the vertical axis. And so their red line is not showing up at the moment, so I am going to have to zoom out. So I want to zoom out until I find the red line. So I see the red line up here close to the 50, and we had it set at 48, so that's good. But I'm not seeing enough detail on the blue line. So I can click here, and it does give me an ordered pair. And so I actually do have my answer there, that the x that we didn't know is such a small decimal. So again, I'm going to go over here to the wrench, and I'm going to click on that, and I'm going to change my graph so that we can see a little bit more detail and make sure that that is truly the point that we want. So on my graph, the y-axis I'm going to let alone because we located our red line, so we know we want that. The x-axis, we think that the decimal we want is just really small, so I'm going to make this go from -1 up to +1 because we think we just want our answer is this really small decimal. Click on the wrench again, and wow, there it is. Now, this is a wild curve because of the negative, the plus in there and everything. This does not have that iconic shape of that we're used to. And with that negative and the subtraction there, this looks more like a logarithmic curve, but you don't need to know that. You just need to be able to use it. So we have here these two, and we can see we do indeed have a curve, so we know we're getting to the right things. And then I'll click on my red line, click on the point, and I get a little bit more detail than I did before, but I do see the value for that x of 0.0288. So I'm going to go here. Ooh, did all kinds of fun things. Yeah, I lost all my writing in my PowerPoint, I think. Nope, there it is. Okay, that was exciting. All right, so I got my ordered pair, and that ordered pair was parentheses 0.0288, comma 48. This was my x, this was my y, and so from that I really found k is 0.0288. That's what it was asking me to find. So I did complete the problem there in the orange. So now I want to go to the problem that's here in the gray, and it asked me, What will be the temperature if the drink is left out for 20 minutes? Okay, so what will be the temperature? Well, the temperature is up here. We decided is the T by itself. And we noted in the orange problem that we solved that it was really the T of T, temperature based on time. So that's what I'm solving for. Now I can fill in a lot of the numbers from what I did before. So I can fill in the 72 as the room temperature, plus, in my parentheses, I'm filling in the 40 minus the 72, just borrowing all this from the work that we did with the question that was there in orange. And then we have the E, and our exponent is negative. And then the exponent in the problem is, let me circle it over here, this negative kt, but we figured out that the value of k is this decimal. So I want to actually plug in that value of k rather than writing k. And I want to plug in the time that they asked me about. But the negative is part of the formula. So negative, the k value is 0.0288. And the time up here is 20. So multiplying that by 20. So now when I look at this, this is calculator friendly. You may be thinking not that friendly, but here we go. So I'm going to simplify just one step like we did on the previous problem. So the 72 plus, doing the math in parentheses here, is negative 32 e to the negative 0.0288 times 20. So I'm going out to my handheld calculator and I am literally typing this. So I'll type 72. I'm not going to type double signs, so I'll type minus 32. And then to get E, we've talked about this before, you're going to use two keys. So you'll use your second key and then you'll use your ln key. So to use that combination, I get E, and my calculator gives it a caret key and a parenthesis because it knows what's coming. And then I'll type negative 0.0288, and I'll put multiply by 20, and I'll end that parenthesis. So I'll give you a moment here while I'm typing. I encourage you to type as well because it's a lot to type. And it's just really good to practice and make sure that you are indeed getting this exactly right. And if you don't get the same answer as I do, then you can just pause the video and go back and try it again and reach out to me then if you need help. So I typed all that into my calculator. And so this was calculating the temperature based on a specific time. So T of T is equal to 54.01, and that would be degrees Fahrenheit based on the context of the original problem. So we kind of did it in a reverse order here. Most of the problems we went to our calculator and did a problem, and then we went to Desmos and did a problem. But in this one, the first half of the problem is when we had that unknown exponent, and that is why we had to use Desmos. And then the second half of the problem, we used our answer, and we were able to put that part in our calculator. So next, I want to grab my Desmos graph. And let me find where that disappeared to earlier. Here it is. And I want to review with you just how we found this graph. So right here, I'm going to default zoom it to home, and I see this little bit of a blue line right by my axis. I know I'm looking for y is 48, so I'm going to use my minus to zoom out. And I found that line up here near the 50, and we thought we had the ordered pair there, but it's really hard to tell. So from looking at it, we sort of see the ordered pair is a decimal, and so then we use the wrench. And we said we think the ordered pair contains a decimal, so we're going to go really small. We're going to go from -1 on the x-axis to +1 so that it zooms in on that. Click the wrench again to get this to go away. and it did zoom in. I'm going to drag it down here so we see a little different window, but we see then that we can click on a line and clearly see with even more detail, more decimals, that value that we wanted. And so we're using our zoom, our plus and minus, and we're also using that wrench tool to really customize the window so that we can see the details that we need.